Okay, welcome to the next video in the systems programming series, still discussing chapter 2 of the textbook, Dive into Systems. Moving on to section C, talking about structs, maybe with a little more detail, probably mostly discussing how to deal with pointer issues when working with C structs. So this is just a bunch of review. So yeah, I don't think there's anything new here. Okay, but what we're going to see here, I think, is that we can use pointers when working with structs. I think, right, well, I don't know, that's a static declaration, so maybe that's not where this is going. Oh, here, but we can use pointers to struct objects. So that's where this is going. And so if we declare, right, as we have up here, that this S pointer is a pointer to this student struct object, then before putting anything, in these memory locations, we need to malloc the size and get the pointer. So we call malloc, we give it the size of what? Its type, which you must write as struct student t. We check for null pointer issues. And right away from having done that, we are now ready to fill the memory locations, right? Like it's not as though in some sense you need to like malloc the space and then put a student object there, which then can be filled. No, it doesn't work like that. You're just ready right away to start filling the memory addresses in that allocated space. So what does this do? This takes your pointer to the struct. We dereference it using the star operator. So now we follow that pointer over to the struct. We call this dot method on its grad year field and assign there the value 2021. You see here another instance of the same basic concept. Now, this is all well and fine. There's nothing wrong with this, but there is because this happens so often, there is this syntax which avoids a lot of the clutter, this star, pointer, dot, age, so on. Well, you can eliminate a lot of that clutter using this syntactic sugar of S pointer right arrow GPA. So that's how you fill the GPA field without having to dereference and then call the dot method. It kind of just does all of that all at the same time. And notice that you can basically use the same logic with with a char field, right? Name was a char field. And so to sort of dereference and call the name field, which can then be sort of filled with the stir copy function call, you can just use this very, very common syntactic sugar for the whole idea. And you can see, I think, what's going on here in the stack and the heap by now hopefully is fairly familiar. Structs can themselves have pointer fields. So instead of statically declaring a char, you can dynamically declare the char. To see an instance of using that, we declare a struct person P1. So P1 just is a struct person. And this is a pointer to a person. In this person instance, we can call its name field and malloc it a certain amount of characters. In this example, 8 of them. And then we give P1 this string. It's worth checking. Do we have the right amount of space? There are 7 characters. We allocated space for 8 characters. That extra character is where the stir copy is going to place the null character. So we allocate, right? This allocates the right amount of space for that call to stir copy. We can assign the value of age in the usual familiar way. Now P2, recall, was, where is it here? A pointer to a struct person T. So we need to malloc it with the appropriate size. Now, because it is, right, because it is a pointer, then we would prefer to use the arrow notation when trying to assign its fields. So rather than the dot notation, because it is a pointer, we use the arrow notation, but everything else looks very similar to the way that we did things before, just using arrows rather than dots, because this is a pointer. I think a lot of this then should make pretty immediate sense, so I'm not going to go through it in too much detail. Okay, here I guess we're basically just making the point that you can make arrays of structs. And so how do you do it? You can do a static declaration. So you say that the name of your variable is classroom1. It's an array of 40 elements. And the elements are of type struct student t. Now that's a static declaration. You can do a dynamic declaration like this. I think that probably makes sense. And so these two are basically equivalent. This is different. This is an array of pointers to struct objects. And so you should imagine that this is, some sequence of cells of memory. There are 40 of them, each one holding a pointer, basically, to somewhere. Who knows where, right? But the point is that there are 40 right, so it is statically declared that this is an array of 40 objects. What are in the objects, or those locations of memory? What's in the array, I guess is another way to say it, is objects of type struct student t star, meaning that they are pointers to student t structs. Okay, so the first two were equivalent, right? Because they are both, right, this is just a static array and this is a dynamic array for the same kind of thing. Or you could just say that it's a pointer to a struct t. I mean, depends on whether or not you malloc after that. But in any case, so you could kind of regard these, as long as you use them both for arrays, then they will be perhaps equivalent. Well, I guess not equivalent because this one could be of any size. But in any case, right? But this one is certainly not equivalent to any of the others because it is a statically allocated array of 40 things, and those 40 things have type struct student t star. I'm not sure, well, yeah, okay, so let's go ahead and just talk about some of these code examples. So because classroom1 was a statically declared array of struct student t objects, then we can access its third index, and what is there it's a struct student t object, it has a field age, and we can assign that the value 20. Classroom 2, we are going to treat as a dynamically allocated array of 15 struct student t objects. Having done that, we can now access its third coordinate, assign its field year to whatever value we choose to assign it. That's all fine. Recall that classroom 3 is an array of struct student t star objects, and so we need to allocate the size of, so I guess I was previously conceiving of this as being for making an array. Oh yeah, that is exactly what's going on, right? Because we are accessing the fifth coordinate here, and in the fifth coordinate only, we are mallocing the necessary memory for a single struct object. But that is right. So what I was initially missing is that this is for just index 5. Okay, and then once that exists, we can use the arrow notation, because that's a pointer, right? What is right here at index 5 is the result of a malloc, so that is a pointer, and so since that is right at 5, we have a pointer, then we use the arrow notation to dereference that pointer, get the age field, and assign it the value 21. You can pass pointers to structs, and in general, I would say most of the time when you're working with structs and you're passing them as arguments to functions, you don't often want to pass them directly, because as we said in an earlier video, that copies all the information of the struct and passes a copy into the function. Now, whether you want to mutate the given object or not You want to design this so that you only pass the pointer, because all of that action, especially for structs which take up a lot of memory, which, as you get to bigger and bigger and more professional programs, your structs are typically going to be large objects carrying lots of data. And if you are always copying it, then that is eating up time and memory. And so for the sake of efficient programs, it is much better if you can find a way to merely pass around pointers to a single location in memory and work that way. So anyways, just for the efficiency of your programs, usually you want to avoid passing structs directly and instead only pass pointers to structs. You get much better performance from your programs when you do it. Okay, but this is how you do it. Here's the syntax. I think the syntax should hopefully make plenty of sense. So I don't know that I need to talk about it. Here's how you call the function. I think that probably makes sense as well. Here is a stack diagram where you have a main function, because over here we have the update ages function, which is not in the main function, but presumably the main function calls this update ages function. And in the main function, we had this classroom2 pointer to a struct. That address got passed into the call to the update ages function. So there, what it calls classroom is just the same address pointing to the same place in memory. And so the function is manipulating precisely the same region of data in the heap. Okay, we can also define self-referential structs. This is good for basically recursively designed data types like linked lists, right? Because a linked list, if you've maybe seen that or not, just roughly speaking, it's kind of like a bunch of nodes and pointers, right? And each node can carry basically data. Let's say that it's equal to 1. But it also contains a pointer, right? And that pointer should point to the next collection of data, but that next collection of data is itself another node, right? So what you want to be able to have in order to design a thing like this is you want a struct that holds data and a pointer. That pointer you want to be able to point to exactly the same kind of data structure. So in a way, this is like a self-referential data structure, which accomplishes recursion, basically. So you can see that designed here. You can have some integer data, but it also needs to have a next pointer. And what does it point to? A struct node, which is exactly the same thing as what we are declaring right now. So this is a self-referential struct. And there's no issue with this. You don't have to really do anything special. It's just a concept you want to learn. So here's, I guess, a demonstration of how to use it. So we declare a struct node star head. So that would be the head node. We also declare a star temp. And it's not the struct itself, but it's a pointer to a struct that presumably we will malloc in just a minute. And also a pointer to temp, which is another struct, I guess. We may or may not malloc that right now, but in any case, let's see what happens, right? So we make the pointer point to null, we malloc, we do our usual testing, we assign values with the arrow notation because it is a pointer. We loop and put some data in. So I don't know, I guess I could talk in detail about exactly how this is working, but fundamentally what it's doing is it is creating the head outside of any loop so that you have something to start with. It's got data equal to 10, pointer pointing to nothing because nothing else exists right now. And then what it's going to do is use the temp to build a new node and then make that new node the head node, right? So the head is getting replaced. This is, I think, like a stack structure where when you put something in, it becomes the new head and it points to the old head. So that if you were to remove the head, then the thing that you get right on next, right at the top there after you've removed the head is whatever came right before it. So it's basically a first in, first out structure. But anyway, I don't know. Do you really want me to talk through the details of this? I think you can read it and probably make sense of it. So let's just end it there.